Hello and welcome back to the Maths Behind Economics YouTube channel. This is the last mathematics mixed question practice in the exponent series, which is also the 13 in the series. But I'll do all I can to make sure that 13 is not turning out to be your unlucky number. So again, what we're going to do is we're going to look at some maths-based questions. So we're going to use again letters which are just generic letters, X's, Y's, A's and B's, rather than specific for economics. I'm going to again explain which rules I'm using, and then in the next video I'm going to look at similar questions but using letters and variables that are very specific for economics. So let's do this. Our first example for this video is going to be 4x cubed y to the negative 4 all over squared times by 3x to the negative 2 y to the 4 all cubed. So what are we going to do with this? Well, I have got two brackets that I need to deal with because brackets are always my priorities. What's inside the brackets? Multiples of different things. So what I'm going to have to do, I'm going to have to raise every single thing that's into the bracket to the power that is outside the bracket. So 4 squared, then I'm going to have x cubed squared, then I'm going to have y to the negative 4 squared. I'm going to do the same for the other bracket with different powers. So 3 cubed, then I'm going to have x to the negative 2 cubed, and I'm going to have y to the 4 cubed. Next up, I still have got loads of brackets because I still have got powers that needs to be raised to other powers. So let's deal with those step by step. So I'm going to have 4 squared, x cubed squared, that's going to be x to the 6th because I have to multiply 3 and 2 together. Y is going to be to the negative 8 because minus 4 times 2 is negative 8. 3 cubed stays. X to the negative 2 cubed is going to be x to the negative 6 because negative 2 times 3 is negative 6. And y is going to be the positive 12 because 4 times 3 is 12. Next thing what I'm going to do, I'm going to change the order around so that the numbers are at the front and x is next to each other and y's are next to each other. So I'm going to have 4 squared times 3 cubed. Then I'm going to have x to the 6 times x to the negative 6 and then y to the negative 8 times y to the positive 12. So I'm going to quickly pick up my calculator and I'm going to calculate what is 4 squared times 3 cubed. And that is 432. Next, I'm going to have to look at x's and y's. So what I need to do, I'm multiplying the same bases. I have to add the powers. 6 add negative 6, that's just going to give me x to the 0. And for the y, I have got negative 8 plus 12, that's going to give me y to the 4. Last step, anything to the 0 power is always 1. So my final answer is 432 y to the 4. That is a lot simpler than this jumble of brackets. Let's look at the second example. A to the 2/3 multiplied by a to the 7/3 plus a to the 1/3. Now we have to be very careful here because there is no rule for adding the same base powers together. The rules are only for multiplications and divisions and raising to the same powers. And as the powers of a are different in here, because one of them is to the 7/3 and the other one is to the 1/3, they are not actually the same quantities. So I cannot just simply add them together and replace it by 2 times the same thing. So unfortunately, I have to do is multiply out the bracket. So I'm going to have a to the 2/3 times a to the 7/3 plus a to the 2/3 times a to the 1/3. What's happening in here now? I have got the same base powers multiplying together, so I can replace it with one base and adding the powers together. I'm going to switch color and I'm going to do some calculations with the fractions on the side. So 2/3 plus 7/3. I'm lucky because they are all thirds, so I can keep just the common denominators and add the numerators together. So I'm going to end up with 9/3, but 9 over 3, that is basically 9 divided by 3, which is 3 itself. So the first power will be simplified to a cubed. What about the second? In the second, I'm going to have to add together 2/3 plus 1/3. Again, they are the same denominator, so I can just simply add the numerators together. That's going to give me 3 over 3. And voila, I'm very lucky again because that's equal to 1. Now, I have to remember that any number to the first power is always giving the base back. So all I have to do now is to replace the second term with a. Problem solved. Much simpler. A cubed plus a. Third example. 3 to the negative 1 x y to the negative 2 all over bracket 9x y squared to the negative third. Wow, a lot's going on in here. First of all, I suggest that we tackle what's in the denominator. So for now, I'm going to leave the numerator as it is. So in the denominator, I have got 3 terms. They all raised to negative 3. So I'm going to break it out and raise the individual terms to the negative 3. And then y is squared, so I'm going to have to raise that y squared to the negative 3. Again, I'm going to leave the numerator as it is, because at the moment I can't really do anything with it because there's a number and 2 different bases. So I'm just going to concentrate on the denominator because there's still a bracket in the denominator. So deal with that bracket. Y is squared and then it's raised to the negative third, so altogether y is raised to the negative 6 because that is a multiple of 2 and negative 3. Now I can start to do things. So I have got 3 to the negative 1 here, and I have got 9 to the negative 3 here. Well, what I'm going to do here, I'm going to leave 3 as it is, but I remember that 9 is actually 3 squared. So I can replace 9 with 3 squared, but 9 has to be raised to the negative third, so I'm going to raise 3 squared to the negative 3 as well. Then I keep the rest of them unchanged. Now next, what I'm going to do, I'm going to keep 3 to the negative 1, x, y to the negative 2, all over. Now 3 is squared and then it raised to the negative 3, so I've got now 3 to the negative 6 because 2 times negative 3 gives me negative 6. I'm going to keep x to the negative 3 and I'm going to keep y to the negative 6. Now, why did I go through all that trouble of rewriting 9 as a power of 3? Well, in the numerator I had 3 and now in the denominator I also have 3. So now I have got the same bases, 3, x and y, both in the numerator and the denominator. So I can apply the rules now when I'm just subtracting the powers. So I've got 3 to the negative 1, take away negative 6, very careful with those pesky negatives, and I have got x. But remember, any number to the first power is always itself. And why is that good for me? Because I remember that now I have power of 1, take away a power of negative 3. And with the y's, I have got y to the negative 2 in the numerator, and now I'm going to take away a negative 6 because that was the power in the denominator. Next step, rewrite all these take away negatives as additions. So 3 is going to be minus 1 plus 6, x is going to be 1 plus 3, and y is going to be minus 2 plus 6. So now the powers are just additions, and now I can carry out those additions. So the final power for 3 is going to be 5 because that's minus 1 plus 6. X is going to the power of 4 because that's 1 plus 3, and y is going to be to the power of 4 again because that is minus 2 plus 6. So that's the result of the third example. Okay, so let's make a little bit more space so we can move on to the next question. Question number 4. Ax squared over b, and the whole fraction is raised to the 4th power, multiplied by x over a squared b cubed, and again the whole fraction is squared, and then the last fraction is b squared over x squared, all raised to the 5th power. Right, we've got 3 fractions here, and each fraction is raised to some power. So how we're going to deal with this? We're going to have to raise the numerators and the denominators separately to the very same powers. In the case of the first fraction, this is going to be ax squared raised to the 4th power over b to the 4th power. And then I have to multiply that with the second fraction, where the numerator is just x, so it's just going to be x squared over the denominator, which is a squared b cubed, and they have to be squared. Last fraction, the numerator is b squared, which have to be raised to the fifth power, and separately the denominator, which is x squared, also have to be raised to the fifth power. What's next? Well, we still have some brackets, so let's deal with them one by one. So in the first bracket, I have ax squared together raised to the fourth power, so I can raise a to the fourth power and x squared to the fourth power separately. B to the fourth does not change. Then I need to multiply it with the second fraction. The numerator stays x squared because there's nothing else in there, but a squared have to be raised to the second power separately, and b cubed also have to be raised to the second power. Then in the last fraction, I can see that the numerator is raised to a power and then a power again, so that's just going to be together raised to the multiple of those two powers, which is going to be 10, because 2 times 5 makes 10. Same goes for the denominator, so that's going to be x to the 10. I still have got some brackets, but now I realize that every single of those brackets are just powers raised to powers again. So what I'm going to do is multiplying those exponents together. So a to the 4 times x to the 8, because 2 times 4 makes 8, and then b to the 4. Multiply by x squared over a to the 4, because 2 times 2 is 4, and b to the 6, because 3 times 2 is 6, and then multiply with b to the 10 over x to the 10. Next step. Now, I have got different variables a, b, and x, and in each of the fractions, I just have them separately to a single power. Now I can start to collect them together. What I have here is a to the 4, and then a to the 4 down here. What does it mean for me? Well, I've got a number, and I divide by that very same number. So basically, they will cancel down to 1. So a disappeared. Now let's look at what's happening with x. So I've got x to the 8 here, I've got x squared here, and I've got x to the 10 down here. Collecting all these together, what will be the power of x? Well, I have got 8 plus 2, because 8 and 2 are up in the numerator, and minus 10, because 10 is down under in the denominator. Then finally moving on to b. So b to the 4th is down here, b to the 6th is down here, and there is a b to the 10 up here. So the power of b will be 10 minus 4 minus 6, because the 4 is down and the 6 is down. So altogether, count what's the power of x. 8 plus 2 makes 10, minus 10 will be 0. What's happening with b? 10 minus 4 is 6, 6 minus 6 is 0 again. So what do I know about anything to the 0 power? That is always equal to 1. So what I end up here with as a solution is a big fat 1. Would you have believed that this jumble of brackets, fractions and powers is just 1 in disguise? Now, after that cliffhanger, let's move on to the last question for this video. X to negative 3 over x to the minus 1/3 multiplied by x to the 6 to the 1/3 multiplied by y squared. Here I've got x to the negative 3 over x to the minus 1/3. So what I need to do is subtract the powers. So it's going to be minus 3 take away negative 1/3. And in the middle term, I've got x 6 raised to the 1/3. So that's just going to be 6 times 1/3, which is 6/3. And y squared comes along for the right. I'm going to make a little bit more space. I'm going to also change color, and we're going to deal with minus 3 plus 1/3, simply because taking away a negative number is always an addition. Now, how do we add a negative whole number and a fraction together? We have to make the whole number to be the same denominator. So we have to express negative 3 as thirds. Well, what cancels down to negative 3 when you divide by 3? Well, that's negative 9. So negative 3 is equivalent to negative 9 over 3 plus 1/3. That's going to give me negative 1/8 altogether. So we can replace x's power in the first term with negative 1/8. Now, if we look at the middle term, I could simplify that to x squared, But then what I see here is now x to the negative 8/3 is multiplied with x squared, and I would have to add the two powers together, and I would have to make it back into thirds again. So to save some work for me, I'm just going to leave the power as 6/3 in the second term, and poor y squared just being dragged along. Let's make a bit more space and then deal with minus 8/3 plus 6/3. What's the result to this? Well, that's just minus 2/3. So the final power of x is going to be minus 2/3, and y squared just stays as it is. Okay, so this is the final result. However, if you really wanted to, because you absolutely can't stand a negative power in the x, you can rewrite this as y squared over x to the 2/3. And again, if you don't want to see fractional powers, you can again go for one more step, and you can write it as y squared over cube root of x squared. Well, whether you want to see the cube root or whether you prefer the negative fractional power up at the top, it's totally up to you. I hope that you've been able to follow through. I also hope that you could pick up some new tricks and that you are becoming familiar with all these manipulations. In the next 3 videos, we're going to keep doing these kind of manipulations, but we are going to concentrate on variables which are common in economics. See you then.